Hi, this is Drew Hamilton. This video is designed to try to explain how to use the CNC in the woodshop at the Gowanus studio space. It's not a very professionally edited video, but hopefully I'll be able to explain programming, machine operation, starting up the machine, etc., to get people started, and then go over maybe some of the things that would hang people up if they don't have specifically experience with LinuxCNC or that much experience at all. A lot of people are coming at this with pretty dramatically different levels of experience, and that's totally fine. So I'm hoping to just have some sort of formal record of best practices, and I can add or subtract from this as we run into things or whatnot. All right, let's get started. So first things first, the most important aspect of learning how to use any CNC or machine of any complexity, I think, is feeling comfortable using the internet as a resource to answer your questions. If I get hit by a bus or there's nobody in the vicinity that knows what's going on, it's super, super helpful to feel like you can solve your own problem. One of the resources that I think everyone should take a look at if they haven't already is the LinuxCNC forum. And I think if you can post in the Slack if you're having a problem, that's great, but it's even better if you can actually post your own questions on here if you think it's a machine-related issue. Even if it's not a machine or LinuxCNC related issue, there's a lot of really helpful people, nerds that basically build CNCs in their spare time. And they will get back to you oftentimes within the hour. So be polite, phrase your question in a way where people want to answer, try to provide as much information as you can. And they're probably going to do a better job than me, frankly. So that's the first thing. Then YouTube is a great resource for learning how to program. I've put together this series of videos for the CNC, and I'd like to post more information that might be relevant from other sources, but you should also be doing that yourself. There's a lot to know about programming, and I couldn't possibly cover all of that myself. So see what you can find online. Fusion 360, HSM Works for SolidWorks, RhinoCam, these are things that you should look at. The bulk of your problems will probably come from very subtle things that are wrong with your programming. All right. All right, in this video I'm giving you kind of an overview of the machine. We're going to see where the limit switches are. This is where the actual limit switch for the y-axis is, and that's the stop for the limit switch. This is the x-axis limit switch and its corresponding stop. For the z-axis, which is the up and down movement of the spindle, it's a little bit harder to find. It's actually further up in the box, but you can sort of see the maximum travel before things collide. So every time you run the machine, you need to home it, and it finds those limit switches. And that basically tells it how far it can go in the negative and positive direction. So the limit switches kind of give it an absolute location that it knows, and I've programmed it so that it can't go too far in the other direction or run off the rails. So when you start the machine, you need to make sure all of these emergency stop buttons are off, and just generally, if you're having problems, that's something that really commonly will screw you up. It'll look like LinuxCNC isn't responsive. Something else is starting the machine on top of the limit switches. That can be kind of a confusing one. So if you turn the power off to the machine, you can actually move it so that it's not on the limit switches, if it is, and then restart the machine. While it's powered on, you're going to have a little bit of a harder time doing that because you won't really be able to do it because the motors will overpower you. So here I am homing the machine. You can go back a little earlier in this video and see which buttons I clicked to do that, and that's basically the first thing that I'm going to do after I've checked to make sure everything is out of the way, that there won't be any collisions during this cycle. So like I said, it just goes, it finds that little bump, and then it goes and drives pretty close to as far as it should realistically go to the left on the x-axis. X-axis is left to right, y-axis is front to back, and the z-axis is positive in the up direction, negative in the down direction. It's a good idea if you're just getting started to maybe even draw a picture of that axis system for yourself. So here I am showing you the hand jog wheel, which is very, very helpful. You can also jog the axes around from LinuxCNC on the computer, but this gives you a very clear picture of which axis you're moving. You can change the increment from x1, x10, x100. X1 is 1/1000th of an inch at a time, x10 is 10/1000ths of an inch, and x100 is 100,000ths, or 0.1 inches at a time, per click, or about 1/8 of an inch. You need to use this to find your zeros when you're setting up your stock to mill. Be a little careful with that x-axis. It can go a little further than when you stop. I'll probably fix that eventually, but not yet.